All right, in our last video, what we did was we saw that we could turn the product of two trig functions into the sum or difference of the angles. Now, we are going to have the same thing, but we're going to do it in reverse. Let me jump to the formulas here first. So now, notice this is not what we've done previously. We had sum or difference of a single angle. So we had two different angles, and we saw earlier that we could just add those two angles up and we could create an equation for that. Here we're literally adding the sine of two entirely different angles. And once we've added them, we see we can derive this formula. The formula is just a trick, basically. Some mathematicians saw that if you made this substitution here, we could create these formulas. So again, I haven't spent much time looking at the derivation of these, but that's the trick that they've done, is they subbed that in to a product to sum formula, and they were able to create this. So again, we're getting kind of obscure here, but suppose, again, someone smarter than me can tell you why. Suppose that we wanted to turn the sum or difference of two entirely different sine or cosine functions into a product. This is how we could do it. So again, a lot of plug and chug, but this is not the same as what we've already done. This was, we're adding or subtracting one single set of angles and then taking the sine. Here we're taking them individually and we can turn them into a product. So again, a lot of plugging and chugging in this. So if I see I have the difference here of two distinct sine functions. Now, here's my formula off my formula sheet. All I got to do is plug and chug here. So my first angle was 4 theta, my second angle is 2 theta. Plugging that in. Simplifying, I get down to this. Okay, so I don't have these down, as you know. So let me see here. So we're doing the sine of 2. Okay, that's going to take me a couple shots here to probably write this down. So sorry, I should have my formula sheet and I do not. Okay, 2 sine of the sum of the angles. Okay, sorry for all that. All right. Now, so alpha here is going to be 3 theta. Beta is going to be theta. So I'm just plugging and chugging. Okay, so what do I got here? I've got 4 theta over 2 cosine 2 theta over 2. Okay, take that one step further, just simplify a little bit more. Okay, so once again, I don't have actual angles, I have just generic angles here, but I can manipulate this. So we're just using the language of mathematics to manipulate this. We turn it into this here. Okay, so here we have some actual values where we have some real values of cosine, and we would like to know the difference. Again, it would probably be easier to just do these on a calculator, but we can show that we can turn this into the product of these two angles. Where I guess in this case what they're going to show us is that this would be, if you only had a unit circle and you didn't have a calculator, this would be beneficial. So we've got our formula here. Again, they're very complicated, but so I'm just plugging and chugging now. It's the addition of these two angles divided by 2, the subtraction of the two angles divided by 2, and we create this. Now, we have real values that we could look up now. So sine of 45 is right equal to 2 over 2. Sine of negative 30 would be down here in the fourth quadrant. So it would be negative 1/2. Simplify this, we get right equal to 2 over 2. Okay, so clever. Again, the age of technology makes it a little bit irrelevant, but it could be done that we could manipulate two different cosine values or sine values, whatever we have that we don't know something about, and we could turn these into the product. Again, kind of hard to do, but okay. This section is going to end here with a few trig identities. Remember how this works. We're going to turn one side into the other. Now, obviously, this right side is so simple, I don't know what I would do. So I'm going to look at this side here on the left. Because it's more complicated, I've got some substitutions. So remember, substitutions, algebra, substitutions, algebra. So we're going to go back. We're going to use, this is a double angle. So, oh, no, yeah, we could have done it like that. I think this is better. Okay, so sorry. So they're going to use this as the sum and difference of two. I should have seen that. That's the section we're in. But I was thinking of these as double angles. I'm sure you could get there that way as well, but this is going to be faster. So look what we have here. This is the difference of two cosines. This is the summation of two different sines. So those are the formulas that we just have been using. So they're just taking these formulas off the front, off our formula sheet here. So for this particular one, we add them, divide by 2, subtract them, divided by 2, etc. here. So again, we're just plugging and chugging. Now, but look what's going to happen here. If we simplify all of this, tidy this up, we get down to here. Now, we have matches on the top and the bottom that can cancel. The 2's can cancel. The sine of 3t's can cancel. And so all we're left with is negative sine of t over cosine of t. Well, by definition, that's tangent. So we have negative tangent. We got it. Okay. Yeah, this is the one I was thinking of. So here they're going to use a double angle formula. So if I'm looking at this, I'm like, I need the right or left side to turn into the other one. I think I'm going with this side because there's pretty limited options. I don't know. You might be able to get there with this. You could try a power reducing formula here. That would probably get it as well. I think that would do it. But let's take a look at the right, and they tell us to use a double angle formula. So remember what our double angle formula said. So we had this turns into this. So I've made that one. Here's what we do. We make a substitution, and then we do our algebra. We've seen this trick before. If we wind up having something over a single fraction, we're going to split it up. We're going to turn it into 1 over sine of 2 theta, 2 sine squared over sine of theta. I just split that like we would do like if we were solving a line. So if we had 3 minus 2x all over 4, we would split it up. We'd give the 4 to both of them. Well, we're going to give the sine squared to both of them. Now, we've done our algebra. There's really no more algebra to do. Well, there's this. We could cancel that. Well, so we've canceled that. Let's do another substitution. 1 over sine squared is cosecant squared. And we've got minus 2 because we canceled the sine squareds, and we've done it. We've turned the right side into the left by just using a double angle formula. Okay, I saw this one. I wasn't quite sure what they were trying to do. It's pretty straightforward. I'll use theirs here. Do you see if tangent and times a cotangent, you're going to get 1 here. So basically the right is too simple. I'm going to work on the left. I don't even know if it's necessary to, I guess I'll show you. So this is tangent, sine over cosine, and cotangent is cosine over sine. You wouldn't even have to do this to know that if they're inverses of each other, you're going to just get 1. But you can cancel everything down here. So this is going to turn out to be tangent times cotangent is just 1 minus cosine squared of theta. Now this one really is so simple, I don't know, it doesn't really use any of the identities in these last sections. Well, how do I get here? There's nothing left to do from an algebra perspective, so I need a substitution. Okay, well, how about this one? We know that cosine squared plus sine squared equals 1 from the Pythagorean identity, so cosine squared must be 1 minus sine squared. We've seen that before. So because I'm trying to get down to sine squared, I'm thinking about this. Here's a formula that turns cosine squared into sines, so let's use it. So I've got 1 minus, and I'm making a substitution. Okay, you make a substitution, then do your algebra. The negative signs are going to make this 1 minus 1 plus sine squared of theta. The ones will cancel. I've got sine squared theta. Okay, some more tools for the tool bag. All this is on your formula sheet, and hope that makes some sense.